Good morning, students. Myself, Dr. T. Sudarshan Ramaperumal, Associate Professor, Department of Electronics and Communication Engineering. Today, we are going to see about the deployment for Raspberry Pi Arduino platform. A decade ago, working around electronic involved knowledge in physical and math expensive lab equipment. The laboratory type setup and important of all love for electronics, but the picture has changed over the decade or so, where the above mentioned factors become relevant to work around electronic expert for last part love for electronics. One such product which made use of the above specified and many other reasons and made electronics be able to reach anyone regardless of their background in the Arduino. Arduino is an open source prototyping platform in electronic based on easy to use hardware and software. Arduino is a microcontroller based prototyping board which can be used in deploying digital devices that can read input like figure on a button, touches, touch on a screen, light on a sensors, etc., and turning it into a output like switching on a LED, routing or a motor, playing songs through a speakers, etc. The Arduino board can be performed to do anything by simply programming the microcontrollers on board by using set of instructions for which the Arduino board consists of USB plugs to communicate with young computers and bunch of connection socket that can wired to external devices like motors, LEDs, etc. The aim of the Arduino is to introduce the world of electronics to people who have small to no experience in electronics like robust designs and architects, etc. This is the simple hardware representation of the Arduino. Hardware and software. Arduino boards are generally based on microcontrollers from Admiral corporations like 816 and 32-bit variant AVR architecture based microcontroller. The important feature of the Arduino board is that standard connectors. Using these connectors we can connect the Arduino board to other devices like LEDs or add-on modules called shields. The Arduino boards also consist of an board voltage regulators and crystal oscillators. These also consist of USB to serial adapters using which the Arduino board can programmed using USB connections. In order to program the Arduino board, we need to use IDE providers by Arduino. Arduino Uno, the most common version of Arduino is Arduino Uno. This board is what most people are talking about when they refer to an Arduino. It's a simple hardware representation of Arduino Uno. Here we have the power plugs and the ground connections, input voltage pins, and the Admiral 381 microcontroller. Some people think of the entire Arduino board is a microcontroller, but this is inaccurate. The Arduino board actually is a specifically designed circuit board for programming or prototyping with Admiral microcontrollers. The nice thing about the Arduino board is that it is relatively cheap, plugs right into the computer's USB ports, and it is that simple to set up. Use open source designs. The advantage of it being open source is that it has a large community of people using troubleshooting it. This makes it easy to find some of help you debug your project. This is Arduino IDE. Here we have the Arduino void setup and void loop of the predefined functions used in the any Arduino program. Please note that although the Arduino plugs into your computer, it is not true USB devices. The board has a special chip that allows it to show up on your computer as a virtual serial port when it is plugged into USB port. This is why it is important to plug the board in. When the board is not plugged in, the virtual serial port that the Arduino operates upon will not be present. It is also good to know that every single Arduino has a unique virtual serial port addresses. This means that every time you plug in different Arduino boards into your computer, you will need to recognize the serial port that is in use. The Arduino has two different types of input pins. These pins analog and digital. Digital input pins only have two possible states, on and off. These two on and step also referred as high or low, 1 or 0, 5 or 0 volt. This input is commonly used to sense the presence of the voltage when the switch is opened or closed. Digital inputs can also be used as the basic for countless digital communication protocols by creating 5 volt or 0 volt. You can create a binary signal, the basics of all computing. This is useful for tracking to digital sensors like ping and ultrasonic sensors or communicating with other devices. Analog inputs, aside from the digital input, the Arduino boards also number of analog input pins. The analog input pins take the analog signal and perform 10-bit analog to digital conversions, turn into the number of between 0 to 1023. This type of input is good for reading the resistive sensors. These are basically sensors which provides resistance to the circuit. They are also good for reading varying voltage signals between 0 to 5 volts. This is useful when interfacing the various types of analog connectivity. If you follow the examples of step 7, the engaging the serial monitor, we can already tried using the analog input signals. Digital output pins are used set to high or low. This allows you to turn on things on and off. Aside from mm, turning things on and off, this form of output is convention for a number of applications. Most notably, it allows you to communicate digitally by turning the pins on and off rapidly. You are creating binary states, which is recognized by countless other electron devices as a binary signal. By using this method, you can communicate using number of different protocols. Digital communication is an advanced topic, but do get a general idea of what can be done. Check out the interfacing within the order pages. If you allowed the example in step 6 for getting a LED to blink, you can already tried using the digital output pins. Thank you.